Imagine yourself settling into the quiet comfort of evening, as the last rays of sunlight fade beyond your window, and the familiar sounds of day gradually dissolve into night's gentle embrace. Allow your breathing to deepen, your shoulders to release the accumulated tension of waking hours, and your mind to embark on a journey across the vast acoustic landscape of our remarkable planet. Tonight, we explore Earth's most mysterious voices, those sounds that drift through deserts and mountains, rise from ocean depths and polar ice, phenomena that have captivated human imagination since our species first paused to listen to the world around us, and which continue to elude complete scientific understanding despite our most sophisticated attempts at explanation. Our planet speaks in languages far older than words, in frequencies that preceded the first human ear by billions of years, in rhythms that shaped the very evolution of hearing itself. These sounds have been constant companions to every generation that has walked, swum, or flown across Earth's surface. Yet they remain wrapped in mystery, resistant to our most advanced technologies and theoretical frameworks. They remind us that despite our remarkable scientific achievements, our ability to split atoms and decode genomes, to send probes to distant planets and peer into the quantum realm, our world maintains its secrets, offering them as gentle gifts to those who still remember how to listen with wonder rather than mere analysis. Consider for a moment the profound timeline of sound on Earth, a history so vast that human existence occupies only the finest sliver at its very end. In the beginning, some 4.5 billion years ago, our planet was a maelstrom of collision and creation. The impacts of countless planetesimals created the first percussion, thunderous beyond imagination, sounds that no ear existed to hear. As the molten surface began to cool, new sounds emerged. The hissing of steam as the first rains fell onto hot rock, lasting perhaps millions of years, creating a planetary sauna whose acoustic signature we can only imagine. The cracking and groaning of cooling stone established patterns of vibration that would echo through geological time, setting frequencies into motion that continue to this day in ways we're only beginning to understand. Long before the first primitive organisms developed the ability to detect vibrations, our planet had already established its acoustic character. The formation of the first oceans brought entirely new sounds into existence. The rhythmic lapping of waves against primordial shores, the deep currents establishing their patterns, the tides beginning their eternal conversation between Earth and Moon. The atmosphere, once formed, became a medium for sound transmission, allowing vibrations to travel vast distances, carrying information about events occurring far beyond the horizon. Wind began its endless improvisation, playing the Earth's surface like an instrument that would never repeat the same melody twice. When life finally developed the capacity to perceive sound, first through simple pressure-sensitive cells, then through increasingly sophisticated organs, it emerged into a world already rich with acoustic information. The earliest organisms that could detect vibrations found themselves surrounded by a complex soundscape that had been refined over geological ages. They adapted not merely to survive within this sonic environment, but to participate in it, adding their own voices to the planet's ever-growing chorus. The clicking of arthropod shells, the movement of primitive swimmers through water, the eventual emergence of vocalization. Each innovation added new layers to Earth's acoustic complexity. We are inheritors of this vast acoustic legacy, though we have perhaps forgotten how to truly hear much of what surrounds us. Modern human ears evolved to detect a narrow range of frequencies, roughly from 20 Hz to 20,000 Hz, missing the vast majority of vibrations that constantly flow through our environment. Below our hearing threshold, the infrasonic world pulses with information. The deep rumbling of distant storms, the movement of ocean waves thousands of miles away, the subtle adjustments of the Earth's crust that precede earthquakes. Above our range, the ultrasonic realm sparkles with its own hidden activity. The navigation calls of insects, the crystalline fracturing of minerals, the subtle songs of turbulence in fluids we perceive as silent. As we begin our journey through Earth's unexplained sounds, we travel first to one of the most ancient and mystifying phenomena known to humanity: the singing sands of the world's great deserts. Picture, if you will, the Gobi Desert as the last light of day paints the dunes in shades of gold, deepening to amber, and finally to the purple gray of approaching night. The air begins its evening cooling, creating thermal currents that dance invisibly above the sand's surface. A gentle breeze stirs, nothing more than you might feel on any calm evening. Yet as it passes over certain dunes, something extraordinary occurs. From the very ground beneath travelers' feet arises a sound that defies easy description or explanation. Some who have heard it compare the sound to the distant tolling of monastery bells, bronze voices calling across impossible distances. Others describe it as resembling the deep resonance of a cello's lowest note, sustained and unwavering, as if a cosmic musician were drawing an endless bow across strings made of sand and wind. Still, others speak of organ music, as if the dune itself had become a vast pipe through which the desert's breath creates melodies both beautiful and unsettling. The sound can be felt as much as heard, vibrating through the body, creating a physical experience of music that seems to emerge from the earth itself. Marco Polo, that intrepid chronicler of wonders whose writings introduced medieval Europe to the mysteries of Asia, documented these sounds during his journey along the Silk Road in the 13th century. His account, written with the mixture of awe and uncertainty that characterizes encounters with the inexplicable, describes how the sands would sometimes fill the air with the sounds of all kinds of musical instruments, and also of drums and the clash of arms. His traveling companions, hardened merchants and warriors accustomed to the dangers of the trade routes, would nonetheless huddle closer together when the dunes began their mysterious song, interpreting the sounds through the lens of their cultural understanding. Some hearing the voices of jinn calling out across the wasteland, others the echoes of ancient battles still being fought in some parallel realm just beyond the veil of ordinary perception. The phenomenon was not unique to the Gobi. Across the world's deserts, from the Sahara to the Namib, from the Arabian Peninsula to the Americas, certain dunes under specific conditions produce these haunting sounds. Each location has developed its own mythology around the singing sands, its own explanations that blend observation with imagination, science with spirituality. The Bedouin peoples of the Sahara incorporated the sounds into their navigation techniques, learning to read the desert's mood through the quality and pitch of the dune songs. They passed this knowledge through generations in poetic oral traditions that encoded practical information within layers of metaphor and meaning. What makes certain dunes sing while others remain forever silent? This question has occupied scientists for generations, leading to investigations that have revealed much while leaving fundamental mysteries unsolved. Researchers have discovered that singing sand requires remarkably specific conditions. The grains must be of uniform size, typically between 0.1 and 0.5 millimeters in diameter. They must be exceptionally dry, free of clay or other binding materials that might dampen vibrations. The sand must contain silica, and the grains should be nearly spherical, polished smooth by centuries or millennia of wind-driven movement, each grain a tiny pearl shaped by patient atmospheric forces. The mechanism of sound production involves the synchronized avalanching of sand down a dune's slip face. As gravity pulls the grains downward, they create a form of acoustic resonance, each grain vibrating against its neighbors in patterns that amplify into audible sound. The frequency produced depends on the size of the grains and the speed of their movement. Larger grains produce lower frequencies, smaller grains higher ones. The most musical dunes are those where all the grains are nearly identical in size, creating pure tones rather than acoustic chaos. Yet even with these requirements identified, mysteries persist that challenge our understanding of granular physics and acoustic science. Why do some dunes produce pure tones while others generate complex harmonies? Researchers have recorded dunes that sing in precise musical intervals, perfect fifths and octaves that would delight any composer. Some dunes produce multiple frequencies simultaneously, creating chords that seem impossible given the uniformity of the sand grains. The dunes near the oasis town of Liwa in the United Arab Emirates produce a fundamental tone around 90 Hz, with harmonics that follow the mathematical patterns of musical instruments. Yet sand is not a string or a column of air. How does it achieve this acoustic organization? Even more puzzling are the reports, consistent across cultures and centuries, of dunes that seem to respond to human presence. Travelers describe how certain dunes remain silent until approached, then begin to sing as if greeting visitors. Others report that the quality of the sound changes based on the listener's emotional state or intention, though such claims venture beyond what conventional science can investigate. Yet the consistency of these reports across different cultures and time periods suggests something worth considering, even if we lack the framework to study it systematically. The Namib Desert, that ancient sea of sand stretching along Africa's southwestern coast, presents its own unique mysteries. Here, where some of the world's tallest dunes rise like frozen waves against the sky, the sounds produced differ markedly from those found anywhere else on Earth. The Namib is possibly the oldest desert on the planet, with some areas having been arid for over 55 million years. The sand here has been shaped by forces operating on geological timescales, creating grains with unique properties that might contribute to their distinctive acoustic signatures. The Sand peoples, who have lived in harmony with this landscape for tens of thousands of years, possess an oral tradition that speaks of these sounds as the Earth's way of remembering. In their understanding, each grain of sand carries within it the memory of the stone from which it came. Memories of mountains that no longer exist, of seas that dried up before humans walked upright, of winds that blew when the world was young. When conditions are right, these memories are released as sound, the planet sharing its history with those who know how to listen. This poetic interpretation, while not scientific in the conventional sense, captures something essential about the deep time represented in these ancient sands. Modern acoustic analysis of the Namib Dunes has revealed frequency patterns that challenge our understanding of granular physics. The sounds sometimes contain overtones that, according to current mathematical models, shouldn't exist given the size and composition of the sand grains. Some researchers have suggested that the extreme age of the Namib sand, with some grains having been weathering and reshaping for over 1 million years, might contribute to these unique acoustic properties. The grains have been polished not just smooth, but into nearly perfect spheres, sorted not just by size but by density and composition through processes operating far longer than human civilization has existed. The internal structure of these ancient grains might also play a role. Unlike younger sands, where grains often retain angular features or compositional variations, the Namib sands have been reduced to their most fundamental mineralogical essence. X-ray analysis reveals crystalline structures of remarkable uniformity, as if millions of years of weathering have created natural acoustic resonators at the microscopic scale. When billions of these tiny resonators move together, they might create emergent properties, sounds that arise from the collective behavior rather than individual grain vibrations. There's also the question of environmental factors unique to specific locations. The Namib Dunes exist in a coastal desert where fog provides the primary moisture source for much of the ecosystem. This fog doesn't wet the sand enough to stop it from singing, but might deposit microscopic amounts of moisture that affect the acoustic properties in subtle ways. The daily temperature variations, extreme even by desert standards, cause the sand to expand and contract in patterns that might contribute to sound production. The interaction between offshore winds and inland thermal currents creates complex air movements that could trigger resonances impossible in simpler wind patterns. Some dunes sing only at specific times of day, often in the early morning or late evening when temperature gradients are most pronounced. Others respond to seasonal changes, their songs varying with the angle of the sun and the moisture content of the air. A few legendary dunes are said to predict weather, changing their tune hours or days before storms arrive, though documenting such phenomena scientifically remains challenging. Travel with me now from the dry expanses of singing sand to the mysterious depths of Earth's waters, where sounds propagate with a clarity and distance impossible in air. Water, that essential medium of life, has its own vocabulary of sounds, many of which remain beyond our complete comprehension. The ocean, covering more than 70% of our planet's surface and containing 97% of its water, is a vast acoustic realm where sound travels faster and farther than in air, where conversations can span entire ocean basins, where mysteries lurk in the darkness beyond the reach of sunlight. In the deepest trenches of our oceans, where pressure would crush most surface life in an instant and darkness is absolute and eternal, strange sounds echo through the liquid darkness. These abyssal depths, more mysterious in many ways than the surface of the Moon or Mars, harbor acoustic phenomena that challenge our understanding of both physics and biology. Sound waves in these extreme environments behave in ways that models struggle to predict, bent and channeled by temperature gradients, salinity variations, and pressure differentials that create acoustic highways and dead zones, amphitheaters and echo chambers on a scale that dwarfs any human construction. The year 1997 brought one of the most intriguing acoustic mysteries of modern times, a sound that captured public imagination and scientific curiosity in equal measure. The National Oceanic and Atmospheric Administration, using a network of hydrophones originally deployed by the United States Navy to monitor Soviet submarine activity during the Cold War, detected an ultra-low frequency sound of unprecedented power. The sound, which lasted for approximately 1 minute, was detected simultaneously by sensors separated by thousands of miles, indicating a source of extraordinary intensity. Scientists nicknamed this phenomenon the bloop, a name that belies the profound mystery it represented. The sound's acoustic signature was unlike anything in the catalogs of known ocean sounds. Its frequency profile suggested a biological origin. It had the characteristic patterns of sounds produced by living creatures rather than geological events. Yet its intensity far exceeded any sound known to be produced by even the largest whales. Blue whales, the largest animals ever known to have lived, produce calls that can be detected hundreds of miles away. But the bloop was audible at distances that suggested a source orders of magnitude more powerful. For years, the bloop captivated both scientists and the public imagination. Speculation ranged from the purely scientific to the wildly fantastical. Some researchers propose that it might be produced by a previously unknown species of giant marine organism, perhaps dwelling in ocean trenches unexplored by humans. Others suggested it could be a new type of geological phenomenon, perhaps related to underwater volcanic activity or the movement of massive ice sheets. The more imaginative interpretations invoked everything from secret military experiments to awakening sea monsters from humanity's mythological past. Subsequent analysis has attributed the bloop to the fracturing and movement of Antarctic ice, specifically large icebergs calving or scraping along the seafloor. This explanation, while satisfying from a scientific perspective, doesn't entirely resolve all questions about the phenomenon. The sound's precise pattern of frequency modulation, its unusual harmonic structure, and certain aspects of its propagation remain subjects of discussion among marine acousticians. The ice origin theory explains the sound's power and point of origin, but leaves questions about why this particular ice event produced such a unique acoustic signature when thousands of similar events occur without generating comparable sounds. But the bloop represents just one voice in an oceanic chorus that plays continuously across our planet, a symphony of known and unknown sounds that we're only beginning to catalog and understand. Throughout the world's seas, mysterious sounds persist, each with its own character and mystery. The Julia sound, recorded in 1999, resembles nothing so much as someone cooing or calling underwater, a vocalization that seems almost human in its tonal qualities, yet originated from a region of the Antarctic where no human presence existed. The upsweep sound has been detected seasonally since 1991, appearing each spring and autumn with remarkable regularity, its source still uncertain despite decades of investigation. The slow down sound, recorded in 1997 like the bloop, decreases in frequency over approximately 7 minutes in a pattern unlike any known geological or biological phenomenon. It's been detected repeatedly over the years, always from the same general area of the Pacific, always with the same characteristic frequency descent that gives it its name. The sound is loud enough to be detected across the entire Pacific basin, yet no definitive source has been identified. Theories range from volcanic activity to massive underwater avalanches to unknown biological sources, but none fully explain all aspects of the phenomenon. Consider the profound reality that sound travels through water with remarkable efficiency, maintaining its coherence over distances that would render it inaudible in air. In the ocean, sound is the primary sense, more important than vision in the eternal darkness below the photic zone. Marine creatures have evolved extraordinary acoustic abilities. Dolphins and other toothed whales use echolocation with precision that exceeds our best sonar systems, creating three-dimensional sound pictures of their environment. Baleen whales produce songs of extraordinary complexity that traverse entire ocean basins, their purposes only partially understood by human scientists. These whale songs deserve special consideration in our exploration of mysterious sounds. Humpback whales, perhaps the most studied of the singing cetaceans, produce songs that can last up to 30 minutes and be repeated for hours. These songs exhibit remarkable structure, phrases combined into themes arranged in sequences that remain consistent across populations. Even more mysteriously, all males in a population sing essentially the same song at any given time, but the song evolves throughout the breeding season and changes dramatically from year to year. How do whales across thousands of miles of ocean coordinate these changes? What drives the evolution of their songs? These questions remain largely unanswered despite decades of research. The Deep Ocean Sound Channel, also known as the SOFAR channel, enables sounds to travel extraordinary distances with minimal loss of energy. This natural phenomenon occurs at depths where temperature and pressure create a sound speed minimum, causing acoustic waves to become trapped and channeled horizontally. Sounds in this channel can travel thousands of miles. A whale calling off the coast of California can potentially be heard near Hawaii. This acoustic highway has existed since the oceans formed, creating a global communication network that marine life has exploited for millions of years. In recent years, scientists have discovered that the ocean itself produces sounds beyond those created by its inhabitants. The interaction of ocean currents creates acoustic signatures that vary with flow speed and turbulence. Internal waves, massive movements of water beneath the surface, generate infrasonic frequencies that propagate for vast distances. The collision of surface waves produces microseisms, tiny earthquakes that create a constant background rumble detected by seismometers worldwide. These physical, oceanographic sounds form a baseline acoustic environment that marine life has evolved within, a planetary rhythm that influences behavior and communication in ways we're only beginning to understand. The Antarctic continent, that frozen laboratory at the bottom of the world, offers its own catalog of mysterious sounds that emerge from the interaction of ice, water, and wind. The Ross Ice Shelf, a floating platform of ice approximately the size of France, has been discovered to be Earth's most unexpected and perhaps largest musical instrument. This massive structure, hundreds of meters thick and extending far out over the Southern Ocean, vibrates continuously at frequencies almost too low for human ears to detect. As winds blow across the shelf's surface, they cause the entire structure to resonate like a colossal drum or string instrument. The discovery of this phenomenon came somewhat by accident when scientists studying the ice shelf structure placed seismic sensors on its surface. These instruments, intended to measure ice movement and stability, instead revealed that the ice shelf was singing, producing a continuous drone punctuated by rises and falls in pitch that corresponded to changes in wind speed and direction. What makes this discovery particularly fascinating is that the ice appears to be singing about its own condition, providing an acoustic window into its structural health. The frequency and quality of the tones change as snow accumulates or melts, as the surface texture evolves, as cracks form or heal, as the internal temperature of the ice fluctuates through the seasons. Scientists have described it as if the ice shelf is constantly reporting its status through sound, a natural monitoring system that has been operating for millennia without any human awareness of its existence. The mechanism behind this ice music involves the creation of pressure waves in the top layers of snow and firn, compressed snow that hasn't yet become solid ice. Wind moving across surface features, ridges, valleys, sastrugi, wave-like formations created by wind erosion, creates turbulence that translates into vibrations. These vibrations propagate through the ice mass, with different frequencies traveling at different speeds and depths. The result is a complex acoustic environment where multiple tones interact, creating harmonics and interference patterns that give the ice shelf its unique voice. Local variations in the ice song correspond to both visible and hidden features of the shelf. Areas where the ice is under particular stress sing differently than regions in equilibrium. Crevasses act like organ pipes of varying lengths, each contributing its own pitch to the overall composition. During the Antarctic summer, when melting creates temporary streams and pools on the ice surface, entirely new sounds join the composition, gurgles and splashes and drips that add temporal variation to the ice shelf's basic eternal drone. The implications of this discovery extend beyond mere curiosity. The ice shelf's song might serve as an early warning system for potentially catastrophic changes. As climate change affects polar regions, the frequency and character of the ice music could indicate structural weaknesses developing before they become visible. Some researchers have proposed that long-term monitoring of these acoustic signatures could provide insights into ice shelf stability that traditional measurement methods might miss. Ancient ice cores extracted from Antarctica's interior have revealed that this frozen continent has been accumulating its acoustic history layer by layer for hundreds of thousands of years. Each snowfall brings its own subtle contribution to the ice's acoustic properties. As these layers compress into solid ice under the weight of subsequent accumulation, they preserve a record not just of atmospheric conditions but potentially of the sounds that accompanied their formation. The ice contains tiny bubbles of ancient atmosphere, and when cores are brought to the surface and the pressure released, these bubbles pop with sounds that are, quite literally, echoes from the past. Some researchers have speculated that if we could find a way to play back these ice cores with sufficient sensitivity, we might hear echoes of ancient storms, volcanic eruptions that changed global climate, or even the calls of long-extinct creatures. While this remains highly speculative, the idea that ice might serve as a kind of natural recording medium for ancient sounds captures the imagination and reminds us how much we still don't understand about the preservation and transmission of acoustic information through geological time. Moving northward from Antarctica's icy expanse, we encounter another fascinating acoustic phenomenon of the polar regions. Lake Baikal in Siberia, the world's oldest and deepest freshwater lake, produces some of the most mysterious ice sounds on Earth. During winter, when the lake freezes to depths of several meters, the ice creates an acoustic environment unlike anywhere else on the planet. The sounds have been variously described as resembling musical notes, alien communications, whale songs, or whispered conversations in unknown languages. The Buryat people, indigenous to the Baikal region, have long considered these sounds to be the lake speaking or singing. Their oral traditions describe the ice sounds as the voice of the lake's spirit, communicating with those who know how to listen. Different sounds are said to have different meanings. Certain tones warn of approaching storms, others indicate where fish are gathering under the ice. Still others are simply the lake expressing its moods and memories. From a scientific perspective, the sounds are created by the tremendous forces acting on the ice as it expands, contracts, cracks, and reforms in response to temperature changes. Baikal's ice is exceptionally clear, so transparent that one can see through 2 meters of it as if looking through glass. This clarity results from the lake's remarkable purity and the specific conditions under which the ice forms. The acoustic properties of this ultra-clear ice differ from those of normal lake ice, possibly contributing to the unique sounds. The ice creates several distinct types of sounds. There are sharp cracks like gunshots that can be heard for miles, created when thermal stress causes sudden fractures. There are long, singing tones that seem to slide up and down in pitch, produced by ice sheets grinding against each other. Most mysteriously, there are sounds that resemble voices or music. Complex patterns that seem too structured to be random, but have no obvious physical explanation. These vocal-like sounds are most common during specific weather conditions, particularly when rapid temperature changes create maximum stress in the ice sheet. Recording and analyzing Baikal's ice sounds has revealed frequency patterns that don't match theoretical predictions. Some sounds contain harmonics that suggest resonance chambers or acoustic amplification mechanisms that shouldn't exist in a relatively flat ice sheet. The lake's great depth, over 1,600 meters, might play a role, creating unique acoustic conditions as sounds bounce between the ice surface and the lake bottom. The surrounding mountains could also contribute, reflecting and focusing sounds in ways that create unexpected acoustic effects. Now let us turn our attention to one of the most culturally significant acoustic mysteries of the polar regions: the sounds that sometimes accompany the aurora borealis, those dancing curtains of light that have inspired wonder and mythology throughout human history. For generations, people living beneath the northern lights have reported hearing sounds during particularly intense displays. The descriptions are remarkably consistent across cultures and centuries: crackling like static electricity, whooshing like wind despite still air, rustling like silk fabric, or clapping sounds resembling distant applause. From a conventional scientific perspective, these reports present a significant puzzle. The aurora occurs at altitudes of 80 to 300 kilometers above Earth's surface, in regions where the air is far too thin to propagate sound waves that could reach the ground. Sound requires a medium dense enough for compression waves to travel through, and at auroral altitudes, the atmosphere is so rarefied that it's essentially a vacuum from an acoustic perspective. Yet the reports persist, from Scandinavian folklore to Inuit oral traditions to modern eyewitness accounts from aurora tourists and researchers. The consistency of these reports across cultures that had no contact with each other suggests something real is being experienced. The Sami people of northern Scandinavia have long held that the aurora's sounds are the voices of the departed, traveling across the bridge between the world of the living and the realm of spirits. Their tradition speaks of showing proper respect when the lights appear, avoiding whistling or singing that might attract unwanted attention from these traveling souls. Similar beliefs appear in Inuit culture, where the lights are sometimes described as spirits playing with walrus skulls, the sounds being the clicking of bone against bone. Finnish folklore provides the term revontulet, meaning foxfires, from a myth about an Arctic fox whose tail sweeps up snow crystals as it runs across the tundra, creating both the sparks that become the aurora and the crackling sounds observers report. The Finnish word for the aurora literally translates to fire fox, and the associated sounds are said to be the fox's fur crackling with static electricity. These cultural interpretations, developed over thousands of years of observation, often contain remarkable insights that align with modern scientific understanding, even if expressed through metaphor rather than equations. Recent research has proposed a fascinating explanation that, while partially solving the mystery, opens new questions about the relationship between electromagnetic phenomena and human perception. Scientists have discovered that during powerful geomagnetic storms, the same events that create visible auroras, electrical discharges can occur much closer to the ground than previously thought. These discharges happen at altitudes of just 70 to 100 meters, often at the tops of trees, buildings, or other tall objects that can accumulate electrical charge. When the electromagnetic conditions are right, these objects can discharge electricity into the surrounding air, creating the crackling, clapping, or whooshing sounds that people associate with the aurora. This would explain why the sounds seem to correlate with visual changes in the aurora. Both are caused by the same geomagnetic activity, even though the sounds originate much closer to the observer than the lights. It also explains why the sounds are more commonly reported during the most intense auroral displays, when the electromagnetic effects extend furthest down into the atmosphere. Yet this explanation doesn't account for all aspects of the phenomenon. Why do only some people hear the sounds while others standing nearby hear nothing? There seems to be significant individual variation in the ability to perceive auroral sounds, suggesting that personal factors, perhaps related to the sensitivity of hearing, the electrical conductivity of the individual, or even psychological factors, play a role. Some researchers have proposed that certain people might be more sensitive to electromagnetic fields, effectively hearing the aurora through mechanisms we don't yet understand. There's also the question of timing. Many observers report that the sounds synchronize precisely with visual changes in the aurora, occurring simultaneously with particularly bright flashes or rapid movements of the curtains of light. Given that the aurora occurs at high altitude and any ground-level electrical effects would have a different timing, this synchronization remains puzzling. Some scientists suggest that our brains might be creating the synchronization, matching sounds to visual stimuli even if they're not perfectly aligned in time. The possibility that electromagnetic fields might directly stimulate auditory perception without creating actual sound waves opens fascinating questions about the nature of sensory experience. Laboratory experiments have shown that strong electromagnetic fields can sometimes induce the perception of sounds, clicks, buzzes, or hums, through direct stimulation of the auditory nerve or brain regions involved in hearing. Could the intense electromagnetic activity during auroral displays create similar effects in sensitive individuals? Let us turn our attention now to a different category of Earth's mysterious sounds, those that seem to emanate from the solid ground itself, from mountains and rocks that sing, hum, or ring. when conditions align in ways we don't fully understand. Around the world, certain locations have become known for persistent, low-frequency sounds that challenge our understanding of both geology and human perception. The town of Taos, New Mexico, situated in the high desert of the American Southwest, has given its name to one of the most studied yet still unexplained acoustic phenomena of modern times. Since the early 1990s, approximately 2% of the population in and around Taos has reported hearing a persistent, low-frequency humming sound, often compared to the sound of a distant diesel engine idling or a refrigerator running in another room. The sound is described as being more prominent inside buildings than outside, louder at night than during the day, and sometimes pulsing with a rhythm reminiscent of a heartbeat. What makes the Taos hum particularly intriguing is its selective nature. In any given location, some people hear it clearly while others hear nothing at all. Families living in the same house report different experiences. One person driven to distraction by the constant hum, while others remain blissfully unaware of any unusual sound. This selectivity has led to extensive investigations that have systematically ruled out most conventional explanations. Industrial sources were the first suspects, but the hum persists in areas far from any industrial activity. Highway noise, electrical infrastructure, underground pipelines, telecommunications equipment, all have been investigated and eliminated as sources. The sound doesn't correlate with any measurable acoustic phenomenon that instruments can detect. Professional audio equipment that can register sounds far below the threshold of human hearing, often detects nothing unusual in locations where people report the hum as overwhelming. Some researchers have proposed that the hum might result from the interaction between Earth's natural electromagnetic field and certain geological formations. The theory suggests that under specific conditions, electromagnetic waves could induce vibrations in rock formations or groundwater, creating acoustic waves at the very edge of human perception. This would explain why only some people can hear it. Individual variations in hearing sensitivity, particularly at low frequencies, are substantial. It might also explain why the hum seems louder indoors, where the acoustic properties of buildings could amplify certain frequencies. Others suggest the hum might be a form of objective tinnitus, actual sounds generated within the ear or auditory system rather than in the external environment. Unlike subjective tinnitus, which is a phantom sound created by the brain, objective tinnitus involves real physical vibrations, often caused by blood flow or muscle contractions near the ear. Environmental factors unique to certain locations might trigger these internal sounds in susceptible individuals. The Taos hum is not unique. Similar phenomena have been reported in Bristol, England, where residents have complained of a persistent hum since the 1970s. In Windsor, Ontario, the Windsor hum has been documented since 2011, sometimes strong enough to vibrate windows and walls. Kokomo, Indiana experienced a hum outbreak in the 1990s that affected dozens of residents. Each location has its own acoustic signature, its own pattern of who can perceive the sound, and when it becomes most noticeable. The global distribution of hum reports has led some researchers to propose planetary-scale explanations. Could these hums be related to global electromagnetic phenomena, like the Schumann resonances? Might they result from the interaction between solar wind and Earth's magnetosphere? Some have suggested connections to tectonic activity, proposing that the hums might be early warning signs of geological stress that will eventually result in earthquakes, though no clear correlation has been established. Mountains themselves sometimes produce sounds that defy easy explanation, adding their voices to Earth's mysterious chorus. In Venezuela, Cerro Autana, a massive tepuy table mountain, sacred to the Piaroa people, contains a cave system that acts as a natural wind instrument of enormous proportions. As air pressure changes and winds shift, the mountain produces tones that can be heard for miles, sometimes deep, organ-like notes that seem to emerge from the earth itself, other times higher pitches that sound almost like singing or whistling. The Piaroa interpret these sounds as the mountain speaking, sharing wisdom with those who know how to listen. Their shamanic traditions include practices for interpreting the mountain songs, reading messages about weather, seasonal changes, and spiritual matters in the varying tones. From a scientific perspective, The mountain's acoustic properties result from its unique geology, a network of caves and passages carved by millions of years of water erosion, creating resonance chambers of varying sizes and shapes. What makes Cerro Autana particularly interesting is the complexity and variability of its sounds. Unlike a simple wind-through cave whistle, the mountain produces elaborate compositions that change based on multiple factors: wind speed and direction, atmospheric pressure, humidity, temperature, even the time of day. The interplay between different cave openings creates interference patterns that can produce beat frequencies and harmonics. During certain weather conditions, observers report that the mountain seems to sing in harmony with itself, multiple tones combining into chords that would not be out of place in contemporary experimental music. The Himalayas, Earth's mightiest mountain range, generate their own mysterious acoustic phenomena that have puzzled travelers and scientists alike. Throughout the high valleys and passes, people have reported hearing sounds resembling trumpets or horns echoing through the mountains, particularly before weather changes. These sky trumpets, or mountain horns, have been recorded but never fully explained. They differ from avalanche sounds or normal wind noises, having a distinct tonal quality that seems almost musical or intentional. Some scientists propose these sounds result from the interaction between temperature inversions and mountain topography. In mountainous regions, cold air can become trapped in valleys while warmer air sits above, creating atmospheric layers with different densities. These layers can act as acoustic waveguides, channeling and amplifying distant sounds in unexpected ways. A sound created miles away, perhaps by wind through a distant pass or ice cracking on a glacier, could be focused and transformed as it travels through these atmospheric ducts, arriving at a listener's location as something completely different from its origin. The phenomenon might also involve standing waves created in valley systems. Just as a pipe organ creates specific pitches based on the length of its pipes, valleys of certain dimensions might resonate at particular frequencies when excited by wind or other atmospheric disturbances. The complex three-dimensional shape of mountain valleys, with their side canyons, ridges, and variations in width and depth, could create acoustic environments capable of producing the varied and sometimes musical sounds observers report. Local populations throughout the Himalayas have incorporated these sounds into their cultural understanding of the mountains. Tibetan Buddhism speaks of the mountains as dwelling places of deities and spirits, with the mysterious sounds being their voices. The tradition of Tibetan singing bowls, which produce sustained tones through resonance, might have been inspired in part by these natural mountain sounds. Some monasteries are positioned in locations where mountain acoustics create particularly significant effects, suggesting ancient knowledge of acoustic geography. Throughout Scotland's Hebrides Islands, another type of geological sound mystery presents itself. Certain rocks on these ancient islands ring like bells when struck, producing clear musical tones that can sustain for several seconds. These ringing rocks, or musical stones, consist of a particular type of basalt formed under specific cooling conditions millions of years ago. The internal crystalline structure of these rocks creates resonance chambers that vibrate at precise frequencies when energy is introduced through impact. What makes these rocks particularly mysterious is the unpredictability of which ones will ring. Two rocks that appear identical, with the same composition and formation history, might produce completely different acoustic responses, one ringing clearly while the other produces only a dull thud. Scientists have used ultrasound imaging to examine the internal structure of ringing rocks, finding complex patterns of microfractures and crystal alignments that might contribute to their acoustic properties, but no model yet exists that can predict whether a given rock will ring based on observable characteristics. The rocks continue to ring even when removed from their natural setting, suggesting the sound-producing quality is intrinsic to the stone itself, rather than dependent on how the rocks interact with their environment. However, some researchers have noted that the quality of the ringing can change based on atmospheric conditions. Humidity, temperature, and air pressure all seem to affect the tone and duration of the ring. This sensitivity to environmental factors suggests the phenomenon involves subtle physical processes that we don't fully understand. In Pennsylvania's Ringing Rocks Park, a 7-acre field of boulders creates a natural lithophone that has attracted curiosity seekers and scientists for generations. Unlike the Scottish ringing rocks, which are scattered individually across the landscape, the Pennsylvania rocks exist in a dense field where they rest against and on top of each other. When struck with a hammer, different rocks produce different tones, and some generate multiple harmonics simultaneously. Visitors can play melodies by striking rocks in sequence, creating music from stone. Acoustic analysis of the Ringing Rocks Park has revealed that the rocks vibrate in complex patterns, with different parts of the same rock sometimes resonating at different frequencies. This suggests that the internal structure of the rocks is far from uniform, containing zones with different elastic properties that respond differently to impact. Some researchers have proposed that the rocks might contain natural inclusions or mineral alignments that create the acoustic equivalent of soundboards or resonance chambers. The field of ringing rocks raises questions about how such a concentration of acoustically active stones came to exist in one location. The conventional explanation involves selective erosion. The ringing rocks are harder and more resistant to weathering than surrounding rocks, so they remained while softer stones eroded away. But this doesn't explain why these particular rocks have acoustic properties. Some theories invoke unique conditions during the rock's formation, perhaps involving specific cooling rates or mineral compositions that created the necessary internal structures. Vietnam's Ha Long Bay, with its thousands of limestone islands and hidden caves, creates its own category of geological acoustic mysteries. This UNESCO World Heritage Site, formed over millions of years through a combination of tectonic activity and erosion, contains caves that produce sounds that change with the tides. At low tide, certain caves whisper, creating soft, susurrus sounds like distant conversations. As the tide rises, these whispers become songs, musical tones that vary in pitch and intensity with the water level. The local fishing communities have traditionally used these sounds for navigation, each cave having its own acoustic signature that remains consistent enough to serve as an auditory landmark in fog or darkness. Fishermen pass down knowledge of these cave songs through generations, teaching their children to recognize subtle variations that indicate weather changes or unusual tidal conditions. This traditional knowledge represents a sophisticated understanding of acoustic oceanography developed through centuries of careful observation. Modern acoustic modeling suggests the sounds result from complex interactions between water movement, air pressure, and cave geometry. As tides change, water moves in and out of partially submerged caves, compressing and releasing air in patterns determined by the cave's shape. The limestone structure of the caves, with its many small holes and passages, creates additional resonance effects. Some caves seem to have natural Helmholtz resonators, cavity structures that amplify specific frequencies built into their geology. Yet predicting exactly what sounds a cave will produce remains beyond current capabilities. Two caves with seemingly identical entrances and similar sizes can produce completely different sounds. Some researchers suggest that the internal structure of the caves, including passages too small for human exploration, creates the acoustic differences. Others propose that the surrounding rock structure, including fractures and water-filled voids invisible from the surface, contributes to each cave's unique voice. The phenomenon extends beyond simple tidal effects. During storms, the caves produce different sounds than during calm weather, even at the same tide level. The interaction between waves, wind, and atmospheric pressure creates a dynamic acoustic environment where multiple factors combine in ways that are difficult to model or predict. Some caves seem to respond to distant storms, changing their songs hours before weather arrives, possibly responding to infrasonic waves or pressure changes that precede visible weather. Our journey through Earth's geological sounds would be incomplete without considering the vast symphony of seismic activity that constantly plays beneath our feet. The Earth is never truly still. Thousands of small earthquakes occur daily, most too small to feel, but contributing to a constant background of seismic noise. This microseismic activity creates infrasonic waves that travel through the planet's crust, carrying information about geological processes occurring far from any human observer. Recent discoveries have revealed that the Earth itself rings like a bell after large earthquakes. These free oscillations can continue for weeks or even months after a major seismic event, with the entire planet vibrating at frequencies far below human hearing. The lowest of these frequencies, with periods of about 54 minutes, represents the fundamental mode of Earth's vibration, essentially the planet's bass note. Higher harmonics create a complex chord that gradually fades as the energy dissipates. These planetary oscillations were first definitively detected after the 1960 Chilean earthquake, the most powerful earthquake ever recorded. Sensitive instruments around the world detected the Earth ringing for months afterward. Since then, scientists have recorded these oscillations after every major earthquake, building a library of Earth's seismic songs. Each earthquake produces a slightly different pattern of oscillations, depending on its location, depth, and mechanism, creating a unique acoustic fingerprint. Even more mysteriously, scientists have detected continuous free oscillations, the Earth ringing without any triggering earthquake. These persistent vibrations, discovered in 1998, suggest that our planet is constantly humming at frequencies between 2 and 7 millihertz, far below human hearing but detectable with sensitive seismometers. The source of this continuous excitation remains debated, with theories ranging from atmospheric turbulence to ocean waves to processes deep within the Earth's core. As we delve deeper into Earth's acoustic mysteries, we must consider the electromagnetic symphony that surrounds us constantly, usually below our threshold of perception, but occasionally breaking through in ways that remind us of our planet's electrical nature. Earth exists within a complex electromagnetic environment, bathed in radiation from the sun, bombarded by cosmic rays, and generating its own magnetic field through the dynamo effect of its liquid iron core. These invisible forces create a rich tapestry of electromagnetic phenomena, some of which manifest as sounds when translated into frequencies we can hear. The Schumann resonances represent perhaps the most fundamental of Earth's electromagnetic voices. These extremely low-frequency waves propagate in the cavity formed between Earth's surface and the ionosphere, the electrically charged layer of the upper atmosphere. Lightning strikes around the world, approximately 50 occurring every second, totaling nearly 2,000 thunderstorms active at any given moment. Excite these resonances, creating a constant electromagnetic pulse that has been described as Earth's heartbeat. The fundamental Schumann resonance frequency is approximately 7.83 Hz, with overtones at roughly 14.3, 20.8, 27.3, and 33.8 Hz. These frequencies have remained remarkably stable throughout human history, varying only slightly with changes in the height of the ionosphere or the global distribution of thunderstorm activity. What makes these resonances particularly intriguing is their relationship to human consciousness. They fall within the range of human brainwaves, particularly the alpha and theta states associated with relaxation, meditation, creativity, and the transition between waking and sleeping. Some researchers have proposed that life on Earth evolved within this electromagnetic environment and that our biological rhythms are fundamentally influenced by these planetary frequencies. The human brain's alpha waves, typically 8 to 12 Hz, overlap significantly with the fundamental Schumann frequency. Theta waves, 4 to 8 Hz, associated with deep meditation and REM sleep, also fall within the Schumann range. This correlation has led to speculation that humans and other life forms are electromagnetically connected to the planet in ways we're only beginning to understand. Indigenous traditions from around the world speak of Earth's pulse or heartbeat, descriptions that seem to intuit the existence of these global resonances long before science could measure them. Aboriginal Australians speak of the Earth's songlines, invisible pathways across the land that record creation stories and navigation routes. These songlines are said to have their own frequencies, their own songs that can be felt more than heard. Modern measurements have found that many traditional songline routes correspond to geological features, fault lines, underground watercourses, mineral deposits that could act as waveguides for electromagnetic or seismic waves. The relationship between consciousness and electromagnetic fields raises profound questions about the nature of awareness itself. Throughout history, certain individuals have claimed sensitivity to electromagnetic phenomena, the ability to sense approaching storms, to feel the presence of underground water or minerals, to experience physical effects from proximity to power lines or electronic devices. While some of these claims have been debunked, others remain unexplained, suggesting that human sensitivity to electromagnetic fields might vary significantly among individuals. During geomagnetic storms, when solar wind interacts particularly strongly with Earth's magnetosphere, our planet's electromagnetic voice becomes more complex and sometimes audible through natural radio phenomena. These storms, triggered by solar flares and coronal mass ejections, can induce electrical currents in the ground, cause aurora displays, and create a variety of electromagnetic effects that, when translated to audio frequencies, produce an remarkable array of sounds. Radio operators and researchers have long known about the natural radio emissions that become particularly active during geomagnetic storms. Whistlers are perhaps the most famous of these phenomena, electromagnetic waves created by lightning that travel along Earth's magnetic field lines from one hemisphere to the other and back. When these waves are converted to audio, they create descending tones that sound remarkably like someone whistling a falling note. Each whistler is unique, its exact frequency pattern depending on the path it travels through the magnetosphere and the density of charged particles it encounters. The dawn chorus is another remarkable electromagnetic phenomenon. As the first rays of sunlight ionize the upper atmosphere each morning, they trigger a cascade of electromagnetic effects that, when translated to audio frequencies, sound remarkably like a chorus of birds greeting the day. This electromagnetic dawn song occurs whether or not any actual birds are present, a planetary celebration of the daily renewal of solar energy. The chorus is most intense during geomagnetic storms, when the increased particle density in the magnetosphere amplifies the effect. Hiss is a continuous natural radio emission that sounds like steam escaping or distant ocean waves. It's caused by the interaction of solar wind particles with Earth's magnetosphere, creating broadband electromagnetic noise. During intense geomagnetic activity, the hiss can become loud enough to interfere with radio communications, a reminder of the powerful electromagnetic forces constantly at play around our planet. The interaction between solar wind and Earth's magnetic field creates a vast range of other electromagnetic phenomena, each with its own characteristic sound when converted to audio frequencies. Clicks and pops from distant lightning strikes create a percussion section in Earth's electromagnetic orchestra. Tweaks, short chirps caused by lightning-generated waves dispersing as they travel through the magnetosphere, add melodic elements. Triggered emissions occur when one electromagnetic wave triggers a cascade of others, creating complex patterns that can sound like electronic music or alien communications. Living organisms contribute their own voices to Earth's electromagnetic symphony. Trees, it has been discovered, generate weak electrical fields that fluctuate with their biological processes. During spring's growth surge, these fields intensify, creating electromagnetic signatures that change throughout the day as photosynthesis waxes and wanes. During autumn's preparation for dormancy, the fields shift to different patterns, as if the trees were broadcasting their seasonal transitions. Forests as a whole might create collective electromagnetic fields that could influence weather patterns, animal behavior, and even human consciousness. Some researchers have proposed that the electrical activity of millions of trees in a forest creates a kind of electromagnetic ecosystem, a field of information that sensitive organisms can tap into. While these ideas remain highly speculative and controversial, they're being investigated with increasing sophistication as our instruments become capable of detecting ever weaker electromagnetic phenomena. The role of consciousness in perceiving Earth's subtle sounds and electromagnetic phenomena presents one of the most challenging questions in this field. Why can some people hear the Taos hum while others cannot? Why do some individuals report sensing earthquakes hours or days before they occur, feeling or hearing something that no instrument detected? Why do certain people seem more affected by geomagnetic storms, experiencing headaches, sleep disturbances, or mood changes that correlate with solar activity? These questions touch on the intersection of physics, biology, and consciousness, areas where our scientific understanding remains limited. Consider the possibility that human consciousness might act as a kind of receiver for frequencies and phenomena that exist at the edge of our perceptual abilities. Throughout history, certain individuals have claimed to hear or sense things others could not. From the oracle at Delphi, who may have been responding to geological gases and infrasonic vibrations from tectonic activity, to modern sensitives, who report physical sensations before earthquakes or volcanic eruptions, these claims suggest that some humans might possess sensory abilities that science has yet to recognize or understand. Modern science has confirmed that many animals can perceive frequencies beyond human range. Elephants communicate through infrasound that travels through the ground for miles, coordinating herd movements and sharing information about resources and dangers. These infrasonic calls, below 20 Hz, can travel through solid Earth more efficiently than through air, allowing elephants to communicate over distances that would otherwise be impossible. When elephants detect these ground-traveling vibrations through their feet and trunks, they're tapping into an acoustic world completely hidden from human perception. Dolphins and other cetaceans navigate and hunt using ultrasound with precision that exceeds our best sonar systems. They create three-dimensional sound pictures of their environment, seeing through murky water or in complete darkness. Their echolocation abilities are so refined they can distinguish between objects that differ by mere millimeters in size or detect the internal structure of objects and other dolphins. This biological sonar operates at frequencies up to 150,000 Hz, far above the human hearing range. Many animals show behavioral changes before earthquakes, possibly responding to a combination of signals that precede the main seismic event. These precursor signals might include electromagnetic changes, as rocks under stress generate electrical fields, ground vibrations too subtle for humans to detect, or the release of gases from deep underground. Snakes, with their sensitivity to ground vibrations, often leave their burrows before earthquakes. Dogs and cats frequently show anxiety or unusual behavior hours before seismic events. Cattle and horses have been observed grouping together or refusing to enter barns. If other species have evolved these sensitivities, might some humans retain vestiges of similar abilities? The human nervous system, after all, evolved from the same basic blueprint as other mammals. While our conscious perception might be limited to a narrow range of frequencies, our bodies might still respond to stimuli outside this range. Some researchers have proposed that what we call intuition or gut feelings might sometimes be responses to subliminal environmental cues, electromagnetic changes, infrasonic vibrations, or chemical signals that affect us below the threshold of conscious awareness. As we delve deeper into Earth's acoustic mysteries, we must visit those places where ancient humans demonstrated an understanding of sound that we are only beginning to rediscover. Around the world, archaeological sites reveal that our ancestors possessed sophisticated knowledge of acoustics, creating structures that manipulate sound in ways that suggest deep understanding of vibrational physics and its effects on human consciousness. The Hypogeum of Halsaflieni, in Malta, carved from solid limestone more than 5,000 years ago, contains one of the most remarkable acoustic spaces ever discovered. This underground temple complex, consisting of chambers on 3 levels, includes a room known as the Oracle Chamber with extraordinary acoustic properties. When someone speaks or sings in this chamber at certain frequencies, particularly around 110 Hz, the entire room resonates, amplifying the voice and creating an effect that seems to come from everywhere and nowhere simultaneously. What makes this discovery particularly significant is that the 110 Hz frequency appears to have special properties regarding human consciousness. Recent neuroscience research has shown that this frequency can induce altered states of consciousness, affecting the activity patterns in the language centers of the brain and potentially facilitating spiritual or transcendent experiences. The builders of the Hypogeum, without access to modern measurement tools or understanding of neuroscience, somehow identified and utilized this specific frequency in their sacred architecture. Even more remarkably, 110 Hz appears repeatedly in ancient sacred sites around the world, suggesting this knowledge was either discovered independently by multiple cultures or transmitted through prehistoric networks we don't fully understand. Newgrange in Ireland, a passage tomb older than Stonehenge and the Egyptian pyramids, resonates at this frequency. The King's Chamber in the Great Pyramid of Giza amplifies sounds at 110 Hz. Chambers in ancient temples from Greece to Peru show similar acoustic properties. This consistency across cultures and continents, separated by vast distances and time periods, raises profound questions. Did ancient peoples discover something fundamental about this frequency through experimentation and observation? Is there something inherent in human neurology that makes this frequency particularly significant? Or might this represent preserved knowledge from an earlier, more acoustically sophisticated civilization that influenced multiple later cultures? Stonehenge, that iconic circle of standing stones on England's Salisbury Plain, demonstrates acoustic engineering that seems deliberate rather than accidental. Recent acoustic modeling has revealed that the complete monument would have created an acoustic space unlike anything in the natural landscape. The stones are positioned to create specific patterns of sound reflection and interference. Sound produced within the circle reflects off the stones in ways that create standing waves in regions of acoustic focus. Experiments with scale models and computer simulations suggest that when all the stones were in place, Stonehenge would have had remarkable acoustic properties. Sounds made at the center of the circle would be reflected back to the speaker with a delay of about 0.17 seconds, creating a strong echo effect. This echo would have been particularly pronounced for rhythmic sounds like drumming or chanting, creating a feedback loop that could induce trance states. The acoustic properties of Stonehenge might have been central to its function. The monument's ability to transform and amplify sound would have made it a powerful space for ritual and ceremony. A single voice speaking from the center could be heard clearly throughout the circle, while the acoustic effects would have given that voice an otherworldly quality. Music performed within the circle would have been enriched with natural reverb and echo, creating an immersive sonic environment. In Peru, the temple complex of Chavin de Huantar, built around 1200 BCE, contains some of the most sophisticated acoustic engineering in the ancient world. Researchers have discovered that the temple's builders created a network of underground passages with remarkable acoustic properties. Water flowing through carved channels beneath the temple creates specific frequencies that can induce altered states of consciousness. The sound of running water, amplified and modified by the architecture, would have created a constant drone that prepared visitors psychologically for religious experiences. The builders positioned resonance chambers at precise locations where these water-generated sounds would be amplified. Shell trumpets found at the site, when played in these chambers, produce frequencies that create standing waves in the passages. These standing waves cause disorienting acoustic effects. Sounds seem to come from multiple directions simultaneously. Voices become distorted, and listeners experience the auditory equivalent of optical illusions. The galleries at Chavin were clearly designed with acoustics as a primary consideration. The dimensions of passages, the angles of walls, the placement of openings, all seem calculated to create specific acoustic effects. Some researchers have suggested that priests could have used hidden passages to project their voices into chambers where worshippers gathered, making it seem as if gods were speaking directly to the congregation. The ancient Greeks, renowned for their intellectual and artistic achievements, understood the power of acoustic design in both practical and sacred contexts. Their theaters, carved into hillsides with mathematical precision, demonstrate acoustic engineering that modern architects struggle to replicate. The theater at Epidaurus, built in the 4th century BCE, has such perfect acoustics that a whisper on stage can be heard clearly in the back rows, 60 meters away, without any artificial amplification. But the Greeks went beyond practical acoustics in their sacred sites. At the Oracle of Delphi, one of the most important religious centers of the ancient world, geological investigations have revealed that the temple was built over intersecting fault lines. These faults release ethylene gas, which in low concentrations can induce mild altered states of consciousness. More significantly for our exploration, the faults also create infrasonic vibrations, sounds below the threshold of human hearing, that can nonetheless affect mood and perception. The combination of geological gases and infrasonic vibrations would have created a powerful psychoactive environment. Pilgrims entering the temple would have experienced subtle alterations in consciousness that would have made them more susceptible to suggestion and more likely to interpret ambiguous pronouncements as profound wisdom. The oracle's chamber was designed to amplify these effects, with stone surfaces that would have reflected and focused any infrasonic vibrations. Aboriginal Australians, maintaining perhaps the world's oldest continuous cultural tradition, have always understood the landscape as a vast acoustic space filled with meaning and memory. Their concept of song lines, paths across the land that record creation stories, territorial boundaries, and navigation information, represents one of the most sophisticated systems of acoustic geography ever developed. Each significant location along a song line has its own song, and by singing the appropriate verses, a traveler can navigate across vast distances without any physical markers. The songs encode information about water sources, seasonal changes, and sacred sites. They describe the landscape in acoustic terms. This rock rings when struck, that valley echoes in a particular way. This water source can be heard from a specific distance. Modern analysis has found that many songline routes follow acoustic corridors where sound travels particularly well. They often trace geological features like fault lines or underground watercourses that could act as waveguides for sound. This suggests that Aboriginal peoples developed an understanding of landscape acoustics that allowed them to use natural sound propagation as a navigation aid. The songs themselves, passed down through hundreds of generations with remarkable fidelity, serve as both map and memory. They encode not just geographical information but also history, law, and spiritual knowledge. The acoustic dimension of the landscape becomes a library, with every significant place holding songs that can be accessed by those with the proper knowledge. These ancient acoustic technologies remind us that our ancestors were not primitive in their understanding of sound. They simply expressed their knowledge differently, encoding it in myth, ritual, and stone rather than mathematical equations in scientific papers. They understood that sound could alter consciousness, that certain frequencies had specific effects on human psychology, and that the acoustic properties of a space could enhance spiritual experiences. As we contemplate these ancient sound mysteries, we must also consider Earth's quiet places, those increasingly rare locations where human-generated noise hasn't penetrated, where older sounds can still be heard, where the acoustic environment resembles what our ancestors knew. These acoustic refugees offer glimpses into a world where every sound had meaning and silence itself was a presence rather than an absence. In the deep canyons of the American Southwest, places exist where the only sounds are those that have echoed there for millions of years. The Grand Canyon, particularly in its more remote sections, offers an acoustic experience unlike anything in the modern world. The vast space swallows sounds, creating a silence so profound it becomes almost tangible. In this silence, subtler sounds emerge. The whisper of wind-carved stone, the distant call of a raven that seems to come from another world, the subtle percussion of sand grains shifting in the breeze. Hikers in these deep silences report experiencing a quality of quiet that affects them physically and psychologically. Some describe hearing their own circulation for the first time, their heartbeat becoming thunderous, their breath sounding like wind through a vast cave. Others report a sensation of pressure in their ears, as if their hearing is stretching to fill the acoustic void. Many speak of a profound sense of peace, a quieting of mental chatter that normally fills consciousness. The psychological effects of deep silence have been studied by researchers interested in how modern noise pollution affects human health and cognition. Studies have shown that exposure to natural quiet can lower stress hormones, reduce blood pressure, and improve cognitive performance. The brain, freed from the constant task of filtering out irrelevant noise, can engage in deeper processing and creativity. Some researchers have suggested that regular exposure to natural quiet might be essential for psychological health, something our ancestors took for granted, but we've largely lost. The Amazon rainforest, despite its reputation for cacophony, contains pockets of profound quiet that reveal the sophisticated acoustic ecology of this environment. The forest doesn't produce random noise, but rather a highly organized soundscape where different species have evolved to communicate in different frequency ranges and at different times. This acoustic niche hypothesis suggests that the forest sounds are partitioned like radio stations, with each species broadcasting on its own channel to avoid interference. Just before dawn, there's often a moment when the night chorus has ended but the day singers haven't begun. A pause in the forest's breathing when subtler sounds emerge. In these moments, one can hear the drip of condensation from leaves, each drop a distinct note in a vast percussion ensemble. The creak of growing wood becomes audible. Trees actually make sounds as they grow, their cells expanding and contracting in patterns too slow for normal perception, but occasionally releasing energy as creaks and groans. The almost inaudible rustle of roots extending through soil, the whisper of fungal networks exchanging nutrients, the subtle chemistry of decomposition. All these processes produce sounds at the very edge of perception. Indigenous peoples living in the rainforest often speak of being able to hear the forest thinking, describing a kind of collective consciousness expressed through sound. While science might interpret this metaphorically, the discovery of plant communication through acoustic signals suggests there might be more literal truth to these descriptions than previously thought. Deep caves offer another variety of silence, one that can be disturbing to those unaccustomed to it. In the absolute darkness of a cave, far from any entrance, the absence of visual stimulation heightens auditory perception to an almost painful degree. Cavers report hearing sounds they have never noticed before. The settling of ancient rock, minute adjustments in stone that has been stable for millions of years. The movement of air so slight it would be imperceptible on the surface becomes a presence, a breathing that seems to come from the earth itself. In the deepest, quietest caves, some people report hearing sounds that don't seem to have any physical source. Musical tones, whispers, or rhythmic patterns that might be auditory hallucinations caused by the brain's attempt to process the unusual absence of stimulation. Or they might be genuine phenomena we can only perceive when freed from the acoustic pollution of modern life. The boundary between internal and external sound becomes blurred in these environments, raising questions about the nature of perception itself. The open ocean, far from shipping lanes, presents its own form of quiet that isn't truly silent but rather filled with sounds so consistent they create a kind of white noise of existence. The constant whisper of water against water, the distant crash of waves that have traveled thousands of miles, the occasional splash of a breaching creature. These sounds create a soundscape that hasn't changed significantly since the oceans first formed billions of years ago. Sailors on long ocean voyages often report acoustic experiences that challenge explanation. Voices calling from empty water, music that seems to rise from the depths, the sound of bells where no bells could possibly exist. Some of these might be acoustic mirages, sounds carried impossible distances by unusual atmospheric conditions. Others might be psychological phenomena, the mind creating meaning from the random patterns of wind and wave. But the consistency of these reports across cultures and centuries suggests something more might be occurring. The concept of acoustic pollution brings us to consider how human activity has changed Earth's soundscape in ways that might be preventing us from hearing phenomena our ancestors took for granted. Since the Industrial Revolution, we've added a layer of mechanical noise that now covers much of the planet. Ships create low-frequency noise that travels across entire ocean basins. Aircraft crisscross the sky in corridors of sound. Cities generate a constant hum that extends far beyond their borders. This anthropogenic noise doesn't just mask Earth's natural sounds. It may be preventing us from hearing phenomena that require quiet to perceive. Indigenous peoples often speak of sounds their grandparents could hear that are no longer audible. Not because the sounds have ceased, but because they've been drowned out by the noise of modernity. The morning bird chorus, once a dominant feature of dawn in most inhabited places, now competes with traffic noise. The subtle sounds of seasonal change, the particular quality of wind that announces approaching winter, the underground movements that precede spring, are lost in the constant rumble of human activity. Marine biologists have documented how whale songs have changed in response to ocean noise. Blue whales, the largest animals ever to exist, produce calls that can naturally travel thousands of miles through the ocean. But ship noise now fills the same low frequencies these whales use for communication. In response, some whale populations have shifted their calls to higher frequencies, while others have increased their volume. We're witnessing evolution in real time, species adapting to an acoustic environment that has changed more in the past century than in the previous million years. The effects of noise pollution extend beyond simple masking of natural sounds. Chronic exposure to noise, even at levels we don't consciously notice, has been linked to stress, cardiovascular disease, cognitive impairment, and sleep disturbance. Our bodies evolved in a much quieter world, and the constant noise of modern life represents a form of environmental stress we're only beginning to understand. Some researchers have suggested that the epidemic of anxiety and attention disorders in developed countries might be partially related to the loss of natural quiet. Yet Earth continues to produce new mysterious sounds, as if reminding us that despite our noise and our knowledge, the planet retains its capacity for surprise. In recent years, new phenomena have been detected and reported, sounds that don't fit any known category and resist explanation despite our sophisticated monitoring equipment. Strange booming sounds, dubbed skyquakes, or mystery booms, have been reported worldwide with increasing frequency. These sounds, described as resembling sonic booms or distant explosions, occur without any corresponding aircraft, military activity, or seismic events. They're distinct from thunder, don't correlate with known geological activity, and often happen in patterns that suggest a common but unknown cause. In Clintonville, Wisconsin, a series of underground booms in 2012 caused panic among residents and prompted an extensive investigation. Despite deploying seismometers and other monitoring equipment, scientists couldn't determine the source. The sounds eventually stopped as mysteriously as they began. Similar events have occurred in North Carolina, where the Seneca guns, named after Seneca Lake in New York where similar sounds occur, have been reported for over 150 years. In 2016, residents of the Arctic reported hearing strange sounds from the sea floor, sounds that caused marine mammals to flee the area. The Canadian military investigated, sending aircraft and naval vessels to search for the source. They found nothing unusual, no submarines, no seismic activity, no obvious explanation. The sounds eventually ceased, leaving only questions about their origin and purpose. Some indigenous peoples in the area suggested the sounds were warnings from the Earth about climate change, an interpretation that, while not scientific, captures the unsettling nature of the phenomenon. The forest of Hoia Baciu in Romania has become notorious for a range of unexplained phenomena, including sounds that recording equipment captures but human ears don't perceive at the time. When played back, these recordings sometimes contain what sounds like voices or music, though the patterns don't match any known language or musical tradition. Some researchers have suggested these might be artifacts of the recording process, electronic interference creating the illusion of meaningful sound. Others propose more exotic explanations involving electromagnetic phenomena or even parallel dimensions. Modern technology has revealed that Earth produces sounds far beyond our range of hearing, suggesting that the mysterious sounds we can perceive might be just the tip of an acoustic iceberg. Volcanic eruptions generate infrasound that travels around the globe multiple times, carrying information about the eruption's intensity and character to sensors thousands of miles away. The 1883 eruption of Krakatoa produced infrasonic waves that circled the Earth 7 times, detected by barometers worldwide. Earthquakes create vibrations that make the entire planet ring like a bell for days or weeks after major events, though at frequencies far too low for us to perceive. These free oscillations of the Earth provide information about our planet's internal structure, acting like a planetary ultrasound. The collision of ocean waves generates microseisms, tiny earthquakes that create a constant background vibration felt everywhere on Earth. This oceanic tremor is so consistent that seismologists must filter it out to detect actual earthquakes. These discoveries remind us that we exist within a vibrational universe where everything from the smallest particle to the largest cosmic structure generates frequencies. We are, in a very real sense, living inside a vast musical instrument, one that has been playing since the moment of its formation and will continue until its eventual end. The sounds we can hear are a tiny fraction of this cosmic symphony, and the mysteries we've explored tonight might be windows into this larger vibrational reality. As we approach the contemplative conclusion of our journey, let us consider the philosophical implications of Earth's mysterious sounds. What does it mean to live on a planet that sings? How does recognizing Earth as an acoustic entity change our relationship with the natural world? These questions invite us to reconsider our place in the cosmic symphony and our role as both listeners and participants in Earth's ongoing composition. Throughout human history, cultures have recognized the sacred nature of sound. The Hindu concept of Om represents the primordial sound from which all existence emerged, the vibrational foundation of reality itself. The tradition speaks of Nada Brahma, the world is sound, suggesting that vibration is the fundamental nature of the universe. Modern physics, remarkably, echoes this ancient wisdom. String theory proposes that the fundamental constituents of reality are not particles but vibrating strings, making music the most basic level of existence. The Greek concept of the music of the spheres, developed by Pythagoras and refined by later philosophers, suggested that celestial bodies generate harmonies through their movement. Each planet, in this view, produces its own tone based on its orbital velocity and distance from the center. Together, they create a cosmic harmony too perfect for human ears to detect. We cannot hear it because we have never known its absence, having been immersed in it since birth. Modern astrophysics has discovered that stars do indeed produce sounds, acoustic oscillations that travel through their interiors and cause their surfaces to pulse rhythmically. These stellar songs, though inaudible in the vacuum of space, can be detected through minute variations in starlight. Our own sun rings with millions of different sound waves, creating a complex symphony that helioseismologists use to study the solar interior. In a very real sense, the ancient idea of celestial music has been validated by modern science. Perhaps our attraction to Earth's mysterious sounds stems from an intuitive recognition that we are hearing something essential about the nature of reality itself. When we listen to singing sand or humming ice, we're perceiving the universe's tendency toward pattern and rhythm, its fundamental musical nature expressing itself through material phenomena. These sounds might be glimpses of the deeper harmonic structure that underlies physical reality. The mystery of these sounds also serves an important psychological and spiritual function. In an age where science has explained so much, where satellites map every corner of the globe and submarines explore the deepest trenches, these unexplained sounds remind us that mystery still exists. They provide what psychologists call cognitive escape routes, spaces where imagination can still operate freely, where wonder hasn't been replaced by complete understanding. Children instinctively understand the importance of mystery. They create elaborate explanations for sounds they hear, populating the world with invisible creatures and hidden dimensions. This imaginative engagement with the unknown is not merely childish fantasy, but a fundamental aspect of human cognition. It's how we explore possibilities, how we prepare for the unexpected, how we maintain the flexibility of thought necessary for creativity and innovation. As adults, we often lose this capacity for imaginative engagement with the unknown. We prefer explanations to mysteries, answers to questions. But Earth's mysterious sounds offer an opportunity to reclaim that sense of wonder, to remember that knowing everything would make the world less interesting, not more. They remind us that reality is likely far stranger and more wonderful than our current theories suggest. The selective nature of some phenomena raises profound questions about the nature of perception and reality. Why can only certain people hear the Taos hum? Why do some individuals seem more sensitive to electromagnetic phenomena? These questions challenge the assumption that reality is objective and the same for all observers. They suggest that consciousness might play a more active role in determining what becomes real for each individual. Quantum physics has already demonstrated that observation affects reality at the subatomic level, with particles behaving differently when observed than when not observed. Might similar principles operate at larger scales? Could Earth's mysterious sounds exist in a liminal space between objective physical phenomena and subjective conscious experience? These questions push us beyond the boundaries of conventional science into territories where physics, consciousness studies, and philosophy converge. Indigenous wisdom traditions have always recognized this interpenetration of consciousness and world. They speak of reciprocal relationships with the land, where human attention and intention affect the behavior of natural phenomena. The Aboriginal concept of country includes not just physical landscape, but the songs, stories, and consciousness that animate it. In this view, the land is not a passive backdrop for human activity, but an active participant in ongoing creation. While Western science has traditionally dismissed such ideas as anthropomorphism or projection, the study of consciousness and its relationship to physical reality increasingly suggests that the boundaries between mind and matter may be less distinct than materialist philosophy assumes. The observer effect in quantum mechanics, the role of consciousness in collapsing probability waves into definite states, the phenomenon of entanglement where separated particles remain mysteriously connected. All these suggest that consciousness and physical reality are more intimately connected than we've previously understood. Perhaps Earth's mysterious sounds represent places where this connection becomes apparent, where the normally hidden dialogue between consciousness and cosmos becomes audible. They might not be communications in the sense of encoded messages waiting to be deciphered, but rather manifestations of the ongoing creative interaction between the planet's physical processes and the consciousness that perceives them. We are not passive listeners to Earth's song, but active participants in its creation. Consider how the act of listening itself changes what we hear. When we pay attention to subtle sounds, we develop the ability to perceive ever quieter phenomena. Musicians and audio engineers train their ears to detect frequencies and patterns that untrained listeners miss entirely. Meditation practitioners report becoming aware of internal sounds, the rhythm of breath, the pulse of blood, even the subtle sounds of neural activity that normally remain below conscious awareness. This suggests that consciousness might be trainable, that we can develop sensitivities to aspects of reality that normally remain hidden. Might the same principle apply to Earth's mysterious sounds? Perhaps the planet offers an invitation to develop deeper listening, and those who accept discover an ever-richer acoustic world. The Aboriginal peoples who can navigate by songlines, the Polynesian navigators who sense islands beyond the horizon through wave patterns, the indigenous hunters who can track animals through subtle acoustic cues, all demonstrate that human perception can be developed far beyond what modern life typically requires. This perspective transforms Earth's unexplained sounds from problems to be solved into invitations to relationship. The singing sand doesn't need explanation to be meaningful. Its value lies in the experience of hearing it, in the wonder it evokes, in the way it connects us to all the generations who have heard the same song. The humming ice doesn't require scientific validation to affect us. Its resonance operates below the level of rational understanding, touching something primal in our awareness. We might think of these mysterious sounds as koans, those paradoxical questions in Zen Buddhism that cannot be solved through logical analysis but only through a shift in consciousness. What is the sound of one hand clapping? Has no rational answer, but contemplating it can lead to insights about the nature of reality and perception. Similarly, Earth's mysterious sounds might be nature's koans, inviting us not to solve them but to be transformed by them. The role of mystery in human psychology deserves consideration. Psychologists have found that experiencing awe, that mixture of wonder and incomprehension we feel when confronted with something vast and mysterious, has profound effects on well-being. It makes us feel more connected to something larger than ourselves, more willing to help others, less focused on material concerns. It shifts our perception of time, making us feel like we have more of it. It enhances creativity and openness to new experiences. Earth's mysterious sounds are perfect triggers for awe. They remind us of the planet's vastness and our relatively recent arrival on its surface. They connect us to deep time. The singing sands have been performing for millennia. The ice has been humming since before humans evolved. They hint at realities beyond our current understanding, keeping alive the sense that we live in a universe full of wonders yet to be discovered. As we near the end of our acoustic journey, let us gather the threads we've followed and weave them into a vision of Earth as a living, sounding entity whose mysteries are not failures of our understanding, but gifts to our imagination. Every phenomenon we've explored, from the singing dunes to the humming ice, from the electromagnetic choruses to the ringing stones, represents a different voice in our planet's vast composition. This composition has been playing since Earth's formation 4.5 billion years ago. It began with the violent percussion of planetary accretion, when countless asteroids and comets collided to form our world. It continued through the cooling and solidification of the crust, each fracture and flow adding new rhythms. The formation of oceans brought liquid melodies, while the emergence of an atmosphere introduced wind instruments on a planetary scale. Plate tectonics added the deep bass notes of earthquakes and volcanic eruptions. The evolution of life brought billions of new voices, from the first prokaryotes to the complex choruses of modern ecosystems. We stand now at a unique moment in this vast composition. We have developed instruments sensitive enough to detect sounds from the quantum realm to the cosmic scale. We can record and analyze frequencies far beyond our biological limitations. We can model and predict some of Earth's acoustic behavior with remarkable precision. We've even begun to understand how sound and consciousness interact in the human brain. Yet mysteries remain, and perhaps always will. These remaining mysteries are not failures of science but gifts to humanity. They ensure that no matter how sophisticated our understanding becomes, Earth retains the capacity to surprise us. They guarantee that future generations will have their own discoveries to make, their own wonders to explore. They maintain the delicate balance between knowledge and mystery that keeps life interesting and meaningful. The sounds that science cannot explain also serve as bridges between different ways of knowing. They validate indigenous wisdom that has always recognized Earth as a living, communicating entity. They support contemplative traditions that use sound for healing and transformation. They inspire artists and musicians to create works that celebrate the planet's acoustic creativity. They remind scientists that the universe is likely far stranger and more wonderful than our current theories suggest. Consider the possibility that these mysteries are essential to the human experience, that a world fully explained would be a world diminished. The philosopher Gabriel Marcel distinguished between problems, which can be solved, and mysteries, which can only be explored and experienced. Problems engage our analytical intelligence, but mysteries engage our whole being: emotion, intuition, imagination, and spirit, as well as intellect. Earth's mysterious sounds are mysteries in Marcel's sense. We can study them scientifically, and we should. We can develop theories and test hypotheses, but ultimately, their value lies not in solving them but in experiencing them, in allowing them to expand our awareness of what's possible, in letting them remind us that we live in a universe far more wonderful than we usually remember. As you prepare for sleep, settling deeper into comfort with each breath, imagine yourself as a listener in Earth's grand concert hall. You are surrounded by the planet's mysterious chorus, the distant song of desert dunes shifting in moonlight, the deep resonance of mountain caves breathing with the wind, the electromagnetic lullaby of the Schumann resonances pulsing through your body at frequencies aligned with your own brainwaves. These sounds have accompanied every human who has ever lived. Our ancestors heard them as they gathered around fires in the African savanna, where our species was born. They guided ancient travelers across deserts and oceans. They inspired the first musicians to create instruments that could echo Earth's own songs. The same frequencies that lulled our earliest ancestors to sleep continue their patient performance tonight. The singing sands that guided ancient traders across trackless deserts still offer their navigation songs to anyone who knows how to listen. The humming ice that indigenous peoples interpreted as the Earth's dreams continues its polar meditation, indifferent to whether science explains it or not. You rest now within this acoustic embrace, cradled by sounds that connect you to the vast web of existence. Your heartbeat joins the rhythm of waves on distant shores. Your breath mingles with the wind that plays Earth's geological instruments. The electrical activity of your dreaming brain resonates with the planet's electromagnetic field. You are not separate from Earth's mysterious song, but an integral part of it, both listener and performer in the composition that has been playing since the world began. In the approaching realm of sleep, the boundaries between self and world become increasingly permeable. The mysterious sounds we've explored tonight exist in this same liminal space, neither fully external nor completely internal, neither entirely physical nor purely conscious. They remind us that reality itself might be more fluid, more musical, more mysterious than our waking minds usually acknowledge. Perhaps in dreams we return to a more primal form of listening, one that doesn't distinguish between sounds that science can explain and those it cannot. In that state, all of Earth's voices blend into a single, unified song, a lullaby that has been singing itself since the first moment of creation and will continue long after human ears have ceased to hear. The Aboriginal Australians speak of the dreamtime, when the world was sung into being by ancestral spirits whose voices still echo in the landscape. Modern cosmology speaks of the Big Bang, when all existence emerged from a single point of infinite density and temperature, an event that would have produced the loudest sound in the universe's history had there been any medium to carry it or any ears to hear it. Perhaps these are different languages describing the same fundamental truth, that existence itself is vibrational, that the universe is less like a machine and more like a vast, evolving song. The sounds we've explored tonight might be echoes of that original creative moment, reverberations of the Big Bang still bouncing around the universe in forms we're only beginning to recognize. They might be the universe singing itself into continued existence, each mysterious sound a note in an ongoing composition that creates reality moment by moment. Tonight, as you drift toward sleep, you become part of that cosmic composition. The mysterious sounds of Earth are not separate from you, but expressions of the same creative force that gave rise to your consciousness. In listening to them, even in just imagining them, you participate in the ongoing creation of the world. Your awareness adds something unique to the universe, the capacity for wonder, for appreciation, for love of mystery itself. The singing sands will continue their desert areas whether or not we ever fully understand their mechanism. They've been singing since before humans evolved and will likely continue long after our species has passed into extinction or transformation. Yet for this brief moment of cosmic time, we have the privilege of hearing them, of wondering at their beauty, of adding our own interpretations to the countless others that have accumulated over millennia. The polar ice will maintain its deep humming regardless of our theories. It resonates with frequencies that predate life on Earth, that will outlast our civilizations, that connect our planet to cosmic rhythms we can barely imagine. The ice doesn't care whether we explain its song through physics or mythology or not at all. It simply continues its performance, patient and eternal, a reminder that Earth's mysteries don't depend on our understanding of them. The mountains will go on ringing their stone bells, activated by forces that operate on geological timescales. Each ring carries information about the mountain's formation, its composition, its history of stress and weathering. These geological memories are encoded in frequencies we're only beginning to learn how to read. The mountains have been telling their stories for millions of years. We've been listening for just a few thousand, and listening with scientific instruments for less than a century. The oceans will persist in their mysterious choruses, their bloops and julias, their whistles and moans. The deep waters hold secrets we may never fully uncover. Sounds produced by processes occurring in darkness so absolute and pressure so intense that we can barely imagine the conditions. Yet marine life thrives in these environments, navigating by sound, communicating across vast distances, participating in acoustic ecosystems of stunning complexity. The electromagnetic field will pulse with its planetary heartbeat, the Schumann resonances maintaining their ancient rhythm. These frequencies have remained remarkably stable throughout human history, a constant backdrop to the evolution of consciousness. Some researchers speculate that if these resonances were to change significantly, through some cosmic catastrophe or dramatic alteration of Earth's atmosphere, human consciousness itself might be affected in ways we cannot predict. Yet for now, tonight, the planetary heartbeat continues its reassuring rhythm. It pulses through your body whether you're aware of it or not, synchronizing biological processes, perhaps influencing dreams, connecting you electromagnetically to every other living thing on Earth. You are immersed in this field, swimming in frequencies that link Earth to sky, that carry information from the other side of the planet, that connect our world to the cosmic environment in which it floats. As sleep approaches with its own quiet music, remember that you are never truly in silence. Even in the quietest room, in the stillest night, Earth's mysterious sounds continue. They vibrate through the ground beneath you, pulse through the air around you, resonate in the very atoms of your being. You are immersed in the planet's acoustic ocean, floating in frequencies that science has measured and mysteries that remain unmeasured. The journey we've taken tonight through Earth's acoustic mysteries is also a journey through layers of consciousness, from the analytical mind that seeks explanations to the deeper awareness that is content with mystery. Both are valuable, both are necessary. But in the approach to sleep, we naturally gravitate toward the latter. In this state, explanation becomes less important than experience, understanding less crucial than feeling. The mysterious sounds of Earth invite us into this more receptive state. They ask us to listen without analyzing, to appreciate without explaining, to wonder without needing answers. They offer a form of meditation that doesn't require effort or technique, simply an opening to what is already present but usually unnoticed. In traditional cultures, the time before sleep was considered especially sacred, a threshold moment when the veils between worlds grew thin. The sounds heard in this liminal time were thought to carry special significance, messages from the spirit world or previews of dreams to come. While we might frame it differently today, the essential truth remains. In the transition to sleep, our perception shifts, and we become capable of hearing things that the busy waking mind filters out. Perhaps tonight, in that gentle space between waking and sleeping, you'll hear one of Earth's mysterious sounds. Perhaps the distant echo of singing sand will drift through your awareness, carried on winds of imagination from deserts half a world away. Perhaps the deep pulse of the planetary heartbeat will synchronize with your own, creating a moment of perfect resonance between your individual consciousness and the global field. Perhaps you'll sense rather than hear the great conversation between Earth and cosmos, the electromagnetic dialogue that surrounds us always but rarely enters conscious awareness. Or perhaps you'll simply rest in the knowledge that these mysteries exist, that our world remains far more magical than we often remember. The fact that Earth produces sounds science cannot explain is itself a kind of music, a reminder that wonder and mystery are not relics of a pre-scientific age but permanent features of existence. They tell us that no matter how much we learn, there will always be more to discover. No matter how sophisticated our instruments become, reality will always exceed our ability to measure it completely. The ancient Greeks believed that each celestial sphere produced its own tone, and together they created a cosmic harmony too perfect for human ears to detect. We couldn't hear it because we had never known its absence, having been immersed in it since birth. Perhaps Earth's mysterious sounds are fragments of this celestial music, moments when the cosmic harmony becomes briefly audible to human perception, gifts from a universe that wants to be heard. Modern physics suggests something remarkably similar, that the fundamental forces and particles of nature can be described as different modes of vibration, different notes in a cosmic composition. From this perspective, Earth's unexplained sounds might be windows into the deeper musical structure of reality, glimpses of the songs that hold atoms together and guide planets in their orbits. As you continue your descent towards sleep, let these ideas dissolve into feeling. Let concepts fade into direct experience. The mysterious sounds we've explored don't need to be understood to work their magic. Like lullabies sung in languages we don't speak, their power lies not in their meaning but in their music. They operate at levels deeper than rational thought, touching parts of our consciousness that predate language, that remember when we were not separate from the world but woven into its very fabric. The Earth continues its ancient lullaby, in the singing of sand and the humming of ice, in the ringing of stones and the whispers of wind, in electromagnetic pulses and oceanic choruses. This is the soundtrack of home, the voice of the only world we've ever known, offering its mysterious music to all who remember how to listen. You are part of this music, not separate from it, but woven into its very fabric. Your consciousness is one of the ways the universe listens to itself, one of the instruments through which Earth's song becomes known. In recognizing these mysterious sounds, in wondering at their origin and meaning, you participate in the planet's endless creativity. Sleep now approaches like a tide, carrying you toward shores of dream where Earth's mysterious sounds play without need for explanation. In dreams, perhaps you'll hear the planet's voice more clearly than waking consciousness allows. Perhaps you'll discover that you've always known these songs, that they're encoded in your cells, inherited from ancestors who heard them around ancient fires, carried in DNA that remembers when consciousness first emerged from matter and recognized itself in sound. The boundaries between your body and the Earth are less solid than they appear. The calcium in your bones came from ancient stars, traveled through space as cosmic dust, became part of Earth's geology, moved through soil and water and plants before becoming you. The iron in your blood once flowed in Earth's molten core, rose through volcanic action, weathered into soil, was absorbed by plants and animals in an endless chain that led to this moment. The water in your cells has been ocean, cloud, rain, river, ice, and will be all these things again. In this light, Earth's mysterious sounds are family voices, the songs of your extended body, the vast organism of which you are temporarily a concentrated expression. When you hear the desert sing or the ice hum, you're hearing distant parts of yourself, the greater self that includes but is not limited to your individual existence. The mysterious sounds remind us that we belong here, that we are not strangers on Earth but expressions of its creativity. Every element in our bodies, every thought in our minds, every dream we dream is Earth knowing itself through us. We are the universe becoming conscious of itself, and in hearing Earth's mysterious sounds, we're participating in that cosmic awakening. As this evening's journey nears its end, we return to where we began, with you, settling into rest, surrounded by Earth's ancient voices. But perhaps your listening has deepened through our exploration. Perhaps you'll never again experience silence in quite the same way, knowing now that what seems like quiet is actually filled with frequencies and phenomena beyond counting. Right now, as you prepare for sleep, the world continues its mysterious performance. Somewhere, desert sands are singing their ancient songs under starlight, their voices carrying across empty spaces where no human ear receives them. Somewhere, ice shelves are humming their deep frequencies, vibrating with sounds that influence ocean currents and weather patterns, that affect the migration of whales and the rhythms of seasons. Somewhere, mountains are ringing with the patient percussion of geological time, each sound a moment in conversations that span millions of years. Deep in Earth's oceans, mysterious sounds continue their conversations. Creatures we've never seen might be calling to each other in frequencies we've never detected. Geological processes we don't understand might be generating the boops and whispers that our most sensitive instruments occasionally capture. The ocean keeps its secrets while simultaneously offering clues, maintaining the balance between revelation and mystery that has characterized our relationship with the sea throughout human history. The electromagnetic symphony continues its performance, wrapping Earth in frequencies that connect ground to sky, planet to cosmos. The Schumann resonances maintain their steady pulse, that planetary heartbeat that might influence our own biological rhythms in ways we're only beginning to understand. Aurora displays create their mysterious sounds at the edge of perception, reminding us that light and sound, electricity and magnetism, consciousness and cosmos are more intimately connected than our senses usually reveal. All these phenomena continue whether we're aware of them or not, yet our awareness adds something essential: the recognition of beauty, the experience of wonder, the creative response that turns mystery into meaning. We are the universe becoming conscious of itself, and in hearing Earth's mysterious sounds, we're participating in that cosmic awakening. The mysterious sounds of Earth will be here when you wake, patient and eternal, ready to inspire wonder in all who pause to listen. They are reminders that our planet is not a dead rock spinning in space, but a living, creative entity, constantly generating new forms of beauty and meaning. They assure us that no matter how much we learn, mystery will remain, keeping the world forever interesting, forever new. As you cross the threshold into sleep, you join the great silence that is not empty but full, not absent but present in a different way. In this silence, Earth's mysterious sounds continue their ancient performances, playing for sleeping minds and distant stars, for deep ocean creatures and desert insects, for mountains and forests, and all the spaces between. You are held now in Earth's acoustic embrace, cradled by frequencies that preceded your birth and will continue after your departure. These sounds connect you to every human who has ever wondered at the world's mysteries, to every creature that has ever listened to Earth's voice, to the planet itself as it sings its way through space. Rest now in this cosmic lullaby, this mystery that needs no solution, this song that requires no understanding. Earth's unexplained sounds continue their patient performance, reminding us that we live on a planet of wonders, that mystery and beauty are woven into the very fabric of existence, that the universe itself might be less machine than music, less equation than song. The singing sands, the humming ice, the ringing stones, the electromagnetic choruses, all continue their eternal performances as you drift into dreams. Perhaps in sleeping, you'll hear them more clearly than waking consciousness allows. Perhaps you'll dream of deserts that sing your name, of ice that hums your history, of mountains that ring with your future's promise. Perhaps you'll discover that you've always been part of Earth's mysterious song, that your life is a note in its vast composition, that your consciousness is one of the ways the planet knows itself. Or perhaps you'll simply rest in dreamless sleep, held by the mysterious sounds you cannot hear but which surround you always, the cosmic lullaby that has been playing since the world began and will continue until time itself grows quiet. Either way, you are part of Earth's great composition, a note in its vast symphony, a listener to its endless song. Sleep now, surrounded by mystery, held by wonder, cradled in the ancient arms of a planet that sings. Tomorrow, you'll wake to a world that science has mapped and measured, but tonight you rest in a world that remains beautifully, eternally mysterious. The sounds that cannot be explained continue their performances in the darkness, patient and eternal, mysterious and beautiful, the voice of Earth itself wishing you peaceful dreams. In the morning, the familiar sounds of day will return, the songs of birds greeting the dawn, the whisper of wind through leaves, the distant sounds of human activity resuming. But beneath these familiar sounds, if you listen carefully, you might still hear the mysterious voices we've explored tonight. They're always there, waiting in the spaces between obvious sounds, hiding in the frequencies beyond common perception, singing in the silence that is never truly silent. For now, let go of the need to listen, to understand, to explain. Rest in the knowledge that Earth's mysterious sounds continue whether or not we hear them, that the planet's ancient lullaby plays on through all our sleeping and waking, all our knowing and unknowing. You are part of this mystery, held within it, created by it, returning to it each night in sleep. The journey through Earth's acoustic mysteries comes now to its gentle close, but the sounds themselves continue, eternal and patient, beautiful and strange, the voice of our living planet singing its endless song through the darkness, through your dreams, through the vast and mysterious night that holds us all. Rest now in this cosmic lullaby, knowing that you are never alone, never in silence, always surrounded by the mysterious music of the world that gave you birth and calls you home each night to sleep. Dream now of singing sands and humming ice, of mountains that ring like bells and oceans that whisper secrets. Dream of the electromagnetic embrace that surrounds you always, of the frequencies that connect you to every living thing, of the sounds that science cannot explain but that your deepest self has always known. These are the sounds of home, the voice of Earth itself, singing you to sleep as it has sung to every generation before you and will sing to every generation yet to come. The mystery continues, the music plays on, and you rest within it all, a beloved note in Earth's eternal song.